Good morning and welcome to the American Public Works Association's Talking Top Tech webinar series. Today's panel discussion will be 1 hour in duration and is titled Talking Top Tech Augmented Reality Edition. Due to the format of this program, it is not eligible for CEUs. My name is Rita Cassida and I will be your facilitator today. I am an education manager at APWA, and I have a BS in Mechanical Engineering from Kansas State University and an MS in Engineering Management from the University of Kansas. I am a licensed professional engineer in Kansas, and before joining APWA, I served as the Public Works Director for the City of Lewisburg, Kansas. A recording of today's program will be available in the APWA Members Library and on YouTube within a week. APWA members can log into the library to access the content free of charge. Not an APWA member? Take the members library for a test drive. Spend 2 weeks accessing all the materials in our members library for free. Look for the link to sign up in the email today after the program. Today's session is interactive. So if you have questions for our speakers, please type them into the chat pod. You may do this at any time throughout the program. When you are in full screen mode, you can access the chat pod by hovering the mouse at the top of the screen and clicking on the chat icon. Before we begin today's panel discussion, one of our panelists will give a short presentation. Chuck Lounsbury is the Design Visualization Team Principal at Stantec. Chuck, before you begin the presentation, please give us your brief overview on how you were involved with the implementation of augmented reality. Thank you.
Thanks, Rita. Yeah, as she just said, my name is Chuck Lounsbury, and I work for a global design firm called Stantec, and we are designers. And part of my job is to lead a team of technologists whose job is to be responsible for being forward-looking in technology and bringing in next-generation technology into our everyday workflow. So as part of that job, augmented reality is really a big part of what we're looking at in the coming years. So again, thanks for having me today. And really, I honestly believe that AR is poised to be the next transformative technology in the short coming years. So today, my job is to hopefully give you a basic introduction into what augmented reality is and a bit about how it works. But AR, just something to keep in mind, is that AR is just one of the expanding number of realities in what the industry is starting to refer to as the XR ecosystem. So I'd like to start with a quick recap of what virtual reality is, what VR is, because I think sometimes they get confused and used interchangeably. In reality, is they're much different. So VR, virtual reality, is an artificial digital environment that's designed to completely replace your real-world experience. It's probably the most commonly understood technology in the reality fields. We're seeing it a lot in movies and games and education, and especially in the design fields in the past couple years. So any place where your real life experience, it takes you out of reality and into a virtual space, that is virtual reality. But the key is total immersion. So virtual reality has already made significant entries in how we do our work every day. We use it to enhance our design workflows by helping project managers and clients with design review and clash detection. There's a number of multiplayer environments now that can bring multiple people into a single VR environment at one time to help speed along design process or reduce communication errors. We see it a lot in pre-construction visualization, walking through a site or a designed environment before a shovel goes in the ground. And we see it a lot once the shovel's gone in the ground for specific on-job safety training in areas that are dangerous or conditions that have a higher than normal safety factor. Using VR to rehearse the work has been a big part in, I think, the growing safety culture that kind of permeates the design field. So We've also even gotten to the point where virtual reality can be turned over to the client once you're all done, and they can use it as a O&M tool or a deployment tool for their own safety training. But the point is that it's a technology whose cost and learning curve are low enough now where the adoption can happen on a much wider basis. Like the barriers to get into virtual reality are really low. So now when it comes to VR, the race isn't about the killer piece of hardware. It's really about the customized application for what you're doing. So that is VR in a nutshell. And I think that sort of lays the foundation to move us into augmented reality. So where virtual reality completely replaces the user's real-world environment with a simulated one, augmented reality is the overlay of digital content on a real-world environment. So if you see the real world supplemented with digital effects, that's some sort of augmented reality. In the term of level adoption within the industry or within industries in general, AR is a bit behind where VR is, but the excitement around AR is really, really building. And like I said, it is poised to take off for widespread adoption very, very soon. So every day we're seeing some really exciting and innovative stuff coming out of the AR world. Just logistically, when it comes to AR, there are three main factors that go into defining what the augmented reality tech is. It's the overlay of the real and digital worlds. It's the registration and alignment of that 3D information. And then third is the ability to interact with that combined information in a real-time environment. So fundamentally, AR works by marrying a 3D sensor with a real-time rendering application. So the lens or one of the lenses, and if you have a newer iPhone or Android, on the back of your phone actually has the ability to scan and record depth. It's building a lightweight mesh of everything around you whenever you turn that lens on. The information that's recorded is processed and combined with some sort of 3D information that typically you would be responsible for generating, and then displayed either on your phone or projected into the lens of your smart glasses. So in the example here, you can see that overlay happens in all sorts of ways. Like in the lower image, it's an additional pipe network added into the basement of a hospital, where they wanted to make sure that all the existing pipes and networks worked with what was in the building already. So it was built from an as-built survey and overlaid in there for content. All the way back to Snapchat filters. You know, it's a scan of your face, and they project rainbow vomit onto your face. So it's a 3D registration of information. And actually, that does bring us to the next one. Is the next key component of AR is having the ability to register the existing world to the proposed in either a relative or fixed way. Now I'm going to explain what those are here in a minute, but the first way to register your information is what's called markerless registration. And honestly, I wish it was called something else because there's always some sort of marker. But this is the case where the 3D sensor that you're using, whether it be on your phone or in your headset, is creating a basic 3D mesh of what's in front of you and around you, scanning it and reporting back to the headset the basic definitions of what's in your living room, say. Then you're taking content and manually positioning it on that mesh. So like a really great example of this is the app from IKEA, where you hold your phone up to your living room and wave it around, and it builds a mesh. It figures out floors, walls, and so forth. And then it allows you to take 3D models of their furniture and place it in the room. Now you scale it with your fingers by pinching and pushing, but once it's set in your virtual space, it is looking at your lens through your living room, and you can see what that couch or that chair or whatever is going to be in your living room. So it's the overlay, the overlay of the 3D content, and the registration is manual. It's all spatially referenced. It's just done so in a manual way. Now, the complement to that markerless system is a marker system. And this is where there's a fixed object that serves as both the trigger and trigger for the content as well as a registration point between the real and virtual worlds. So you've probably seen these like the Q codes where you can scan them with your camera and it'll pop up some 3D information. You can also, like in the example in the lower right-hand corner, there's that big Where's Rudolph sign. If you hold the app up to that sign, it in 3D knows the boundaries of that plaza and will put the reindeer up above you, right? So you can move around in that plaza once you scan that sign and see the reindeer from all sorts of angles, but that's the Where's Rudolph sign is your marker that determines not only what to load, but how to keep it referenced within that plaza. So that, like I said, that is the second type of registration known as a marker-based option, marker-based. Now, the last form of 3D registration, and this is where we get into some really, really exciting stuff, is referred to as location-based registration. So this is exactly what it sounds like. Your phone or your headset is constantly keeping track of your location and direction, and now you're using that tracking information to orient yourself in the real world. So you have the ability to use your device to interact with a world of data that is only visible with the right applications and the right permissions. The data is anchored to the real world, like it has an actual fixed space that, and if set up correctly, can be done if it's set up in such a way, can be persistent, so it remains there always. And that model will always be there when you hold up your phone or when you look through your lenses. So in the top picture of this picture here, you can see the HVAC equipment loaded into that building. And that's all a virtual overlay of the 3D models for the HVAC equipment. So that model will be there pre-construction. So if people want to walk through and and use it as part of the bid process to sort of see what the registration is, what people are thinking in terms of models, so they're not looking through document sets, they can go into the floor plate and look at that in a virtual environment. It'll be there during construction. So if you're routing a pipe or you're routing a vent, you could actually turn the lens on and actually see in real space right in front of you where that vent or pipe should go. And then it'll be there in a post-construction world where they'll be able to open up, without having to open up the ceiling, be able to get you pretty close to where sort of the squeaky vent is or the leaky pipe or whatever it happens to be in a post-construction world. So like that is a great example of location-based registration, but that's a very small version of it. There's much larger options out there like Google Maps. There's an app out there called Google Maps AR now where it's no longer giving you directions and plan. It's overlaying you the directions to where you want to go inside of your camera. So as you move your camera around, as you move your phone around, as you look it up to look through it, it tells you, go up here 300 feet and make a right. But you can see the picture there. It actually walks you through the directions, which is great. And so, and to be honest with you, this specific type of registration is poised for, is part of what is helping AR get set to launch. They need to increase the bandwidth of mobile devices a bit, but this is really what's going to help the AR deployment on a larger scale. So the third component for AR is that you need to be able to interact with the combined data in real time. This is such a fundamental concept for smartphone AR users. Think of it like Pokemon Go or any of those apps where you're actually overlaying things in the real world. Like this is just how you use a phone. But really the excitement in this particular factor is when it comes to the adoption of wearable AR devices. Like I said, mobile devices like cell phones and tablets, it's second nature, but both Snapchat and Apple have announced that they are going to be rolling out a commercially available augmented reality headset. And by headset, they actually refer to them as augmented reality glasses. They're no longer the big Darth Vader looking headsets. They're supposed to be fashionable and cool looking. So eventually, this idea, this AR concept has the potential to be constant and persistent part of our lives. It's going to be just how we view the world now or in the future. So those are the three pillars of AR. Those are the overlay of content, the registration of content, and then the real-time manipulation of said content. So that being said, there's two major ways to consume AR, and I've been alluding to them as I go, but just in more depth. There's, like I said, there's two major sets. There's a VR headset, which you can see on the right. The Leap Motion glasses on top, they look like kind of garage doors over your eyes. And then the more prevalent, more announced version of the Hololens, the Microsoft Hololens at the bottom. Those are kind of the two companies who are big enough to lead the AR development on a larger scale when it comes to the VR headsets. Now, the nice thing about a VR headset is that they'll be hands-free. You wear it on your head. There's no need to interact with another device. So all the navigation turns into hand gestures. I know I shouldn't put my hand in front of the camera, but that's how you move things around in an AR world through a headset. They come in a tethered or standalone version, so that if you need to have horsepower, you can plug it into a computer for specific presentations, or more prominently, they'll run autonomously. They're like the Microsoft Surface is a full Windows 10 computer that you wear on your head. Like, it's pretty significant, the amount of tech that's gone into that one. But some of the downsides are that because they're a direct overlay on your vision, so far they've really tried to limit the field of view for the virtual environment so that people don't get confused as to what is virtual and what is real. So the level of immersion has a tendency to be a little bit lower, right? Because they don't want to have someone interacting with something virtual and lose track of the fact that they're in a real world environment. So now, more prevalently, probably the most prevalent of all this tech is mobile AR, and it's by far the most accessible form of AR. So while VR, people have a high level of understanding of it, people have been using mobile AR for years on their phones. Like I referenced Snapchat and Pokemon Go and Google Maps AR. Like, those have all been around for a little while, and they make it really simple and easy to use. Where Apple and Android have really come along is they have decided to not only consume AR, but they are also creating AR. Both Apple and Google have an AR development kit that you can get for low amounts of money. It's fairly simple and straightforward. But every device that in the past 2 or 3 years that both of those giant companies have put out have been both a consumer and, more importantly, a producer of 3D and augmented reality content. So what you're looking at is you now have this global population who is, unbeknownst, been sort of fed AR, like through games and mobile advertising. So now really what we turn into is how do we tailor that information to perform better in businesses, to serve a need, to create a new form of communication, and that's where we're at. Now, I'm not saying that everyone's using AR for the best reasons currently, right? Like, Snapchat filters are wonderful, but I don't know what value they serve the greater good. But the fact is that AR is already in the hands of millions and millions of cell phone users and tablet users, like I said, most of whom don't even know it. And this is why, or one of the reasons why, that the AR industry is going to absolutely explode in the coming years. So to that end, currently AR shows the largest growth potential of all the current XR industries. And like I said, this is something that we keep an eye on at my company, is to make sure that we're always sort of tracking and developing around what's coming next. So when I wrote this slide, the AR market the projection for the AR global market revenue was forecasted to reach over $90 billion by 2022. That's billion with a B, representing more than a tenfold growth compared to when we made the estimate originally in 2017. So in 2017, everybody estimated that's going to get huge and go to $9 billion. In 2018, when they recalibrated the numbers, they said, oh, no, we were off. It's actually 90 billion, but that's just how much growth potential there is within this industry currently. Global audience for AR media is projected to pass more than 1 billion users. Like I said, many of them cell phone users, but with Apple and Snapchat poised to release their own mobile wearable lenses, like this is turning into the way that we consume information going forward. Like this is a really prevalent tech when it comes to it. So, and as far as the AEC industry goes and the design industries go, we've been building in 3D for years, like Revit and ArchiCAD and all those 3D applications, even SketchUp, has changed the way fundamentally that design work gets done to the point where 3D integration is now a commodity process, right? Like everybody should be building in 3D. And what AR does, it actually extends the life of that 3D information out there to the real world. So say you build this really comprehensive Revit model of a hospital. The idea then is that that hospital, the virtual model of that hospital gets sleeved over the top of the constructed hospital so that you'd be able to look at it through an augmented reality lens, be it your phone or smart glasses or however you want to do it, to see, to fully utilize and fully realize the data that's gone into that model. So you'd be able to, I referenced it earlier, you'd be able to turn it over to operations and management to find out where a cutoff switch is. You'd be able to set up a digital twin situation where the building, the smart infrastructure in the building is then feeding your virtual model that you'd be able to interact with. And AR is going to be the bridge that pulls those digital and physical worlds together. So again, like the technology is there, the hardware is there, the audience is there. Really what we're just waiting for is some sort of widespread adoption as to how we can interact with that data. And I think today we're going to go through a couple different options with the panelists here, which are a really exciting group, to explore how people are currently using AR now. Like it's an exciting time. And with that, I'll wrap up and hand it over to the panelists.
Thank you so much, Chuck. That was great information, and I appreciate you sharing that with us today. Now it's time to begin the panel discussion portion of the program. So joining Chuck on the panel is Alec Pestoff. He is the founder and CEO of VGIS. We also have Ashley Riggs. He is the Assistant Director of IT for the City of Auburn, Washington. And Victor Travis is the Civil Designer for the Port of San Diego. APWA is delighted to bring you such knowledge and experience today. We're going to start the program, which each of the panelists giving a brief overview on how they're involved with augmented reality. Alec, would you like to go first?
Absolutely. Thank you very much. My name is Alec, and I'm the founder of VGIS. VGIS is the company that designs augmented and mixed reality solutions for industrial applications. We created a platform that allows us to visualize spatial data for utilities, public utilities, and for AEC companies. We currently work with Chuck, actually companies that Chuck is from, Stuntech, and we worked with Ashley in the past, and currently working with multiple organizations around the world delivering value-added solutions through augmented reality.
Thank you, Alec. Ashley, would you like to go next?
Sure. Thank you, Catherine and Chuck for getting us going on AR. So just again, my name's Ashley Riggs. I'm the Assistant Director of IT at the City of Auburn. Been with the city for almost 15 years now, and obviously within the last 15 years things have changed, not only with my role, but with government IT in general. One thing that was on the slide deck that hopefully you saw is most departments their IT stands for information and technology. And I think what makes our department a little bit unique is that our IT stands for innovation and technology. And that may seem like semantics, but I think it's a real important factor in what we're talking about today and how our mindset is around IT and having that innovation mindset. So one of the things that we've heard already today has really been changed and is kind of a hot topic in the industry is AR. And we had an operational roadblock over the past couple of years on seeing underground utilities above ground. It's kind of, a couple of years ago, that was a crazy concept to say, I need to basically have X-ray vision to see things underground when we're talking about doing locates or finding things. And obviously we had paper maps, we had electronic maps, but being able to see things real time underground is pretty impressive. So what we were able to do is leverage some of the AR technology, some different devices that have been talked about, the Hololens, some iPads, iPhones, in combination with BGIS, and it's allowed us to use real-time AR in the field to do better asset management and better have better data for decision making. So I'm looking forward to talking about it a little bit more in detail with everyone and look forward to it. Thank you.
Thank you, Ashley. Victor, would you like to give your introduction next? Hi, Victor. I think maybe we're having a little technical difficulties. Would you like to give your introduction?
Good morning. Yes. Hi, I'm Victor Travis. I've been with the Port of San Diego for about 3 years and have been in the civil design industry for a little over 20. We here at the Port have gone about trying to create ourselves a 21st century port, 21st century agency, whereby utilizing emerging technologies to better facilitate our facilities and communicate to our stakeholders and personnel what we have going on. And in that, we've used AR to do public outreach. We've used AR to do utility research in the field. As Ashley had mentioned, we've gone about getting most of our utilities verified, scanned, and 3D modeled, and then put into GIS and Civil 3D so that when we have a stakeholder or personnel or one of our service members going out to look for utilities, they can easily find these utilities. And so we here at the Port have decided to go about embracing these new technologies such as augmented reality just to keep up with modern times and be very with keeping up with things. Thank you.
All right. Thank you, Victor. We're going to start with some questions that were submitted. One of them that was submitted in advance, and then we're happy to take any questions from the live audience. So send those in at the chat pod at any time. But the first question was for Ashley in Auburn. Can you tell us how Auburn got started with AR?
Sure. So like I briefly kind of spoke about when I started, 2 to 3 years ago, and we were looking at this, it sounds like there's a lot of similarities on the panelists. Not only were we looking to keep up with trends, if you will, but we were also looking to solve a roadblock that we had. And that roadblock that we kept seeing, which unfortunately happened on a regular basis, was when we were doing underground work. We were kind of flying blind. We had contractors that were digging and could dig up a utility line. We maybe had dug and didn't realize we needed to move over 5 feet or whatever the case was. So the general idea is that obviously we can see things above ground pretty well, but we struggle to see things underground. And so when we were kind of brainstorming on what our options were, is it acceptable to have things within an inch or a foot or a meter within our GIS data and subsequently our asset management system? Was that acceptable, or did we want to reduce our risk and get something a little bit more accurate? And that's kind of where AR came into play. So we partnered with BGIS and we did several different rounds of testing, if you will, different proof of concepts. We started with the Microsoft Hololens, and I mean, it was very, very cool. We talked about some of the different ways to interact, and I could have the HoloLens on, I could be in the field, I could be seeing and interacting with below ground data, I could be calling my supervisor and looking at him in the HoloLens as I'm looking at the data, and we could both be seeing the same thing. Very, very, very cool stuff. The reality was the HoloLens was a little bit harder to work with. a little bit more expensive, so we started transitioning into more Apple products, specifically iPads, where I could just hold up the iPad where I want it to look and easily move that thing around. We talk about the pinch and the zoom, being able to click. I could pull up my email. I could grab a screen grab. I could send it off. Much, much more interactive. And quite honestly, it was very accurate. So we've been playing around with that for a couple years now in different capacities and have seen some real benefits of being able to see underground stuff above ground.
Thank you very much. That was very informative. The next question is for Alec. Where do you see the industry heading in, say, 3 to 5 years? Can you give us some insight into that?
Absolutely. So in terms of industry, we see that, as Chuck mentioned, there will be, or we expect, a tremendous explosion of different AR technologies in general. So if you look at the manufacturing, many manufacturing facilities, advanced manufacturing and regular manufacturing facilities, they try to incorporate different overlays, augmented reality overlays, to supplement the existing processes. Speaking strictly from the spatial information visualization perspective, this is what we're specializing in, we can see that many companies attempting to develop their own tools or components for visualizing spatial data. In our specific space, we see that in the next 3 to 5 years, there will be a wild west of companies. Everybody will try to create their own thing in the next little while. And probably at the end of that 3 to 5 year term, things will start settling and consolidating, and then we will see some leading platform emerging from that wild west of different AR applications. In terms of general technology, Ashley made a very good point about Microsoft HoloLens. I have a couple of devices with me today. So this is the original device we started with Ashley. And although it's not a perfect device, it was the first and the only device of its kind. It's kind of bulky. And due to the design limitations, it's very, very uncomfortable to put on and off and wear, and there are lots of limitations with that. Now, Microsoft came up with this. This is Microsoft HoloLens 2. Much lighter, much more balanced, easier to put on, has a flip-up display. And what we see happening in the next 3 to 5 years is that device of this kind will replace traditional phones and tablets that we have, because they allow you to see augmented reality data in the natural way, most natural way possible, right beside the object that you're trying to work with, while being hands-free to do the actual job. So we see that the industry will head in this direction. Devices of this kind will replace traditional phones and tablets within the next probably 5 years, not so much 3 years, but 5 years. And the entire industry points that there will be a drastic shift from VR-centric to more mixed reality-centric applications.
Thank you. We now have a question from Colleen. What tips and advice do the panelists have for public works teams that are just getting started with AR and VR? Alec, do you want to start with that answer, and then the other panelists can weigh in?
I'd like to start, yes. We have probably 20 to 30 municipalities we're working with. And we've gone through some turnover in that space and some churn as well. And now we start seeing trends as of which municipalities and utilities were successful at adopting AR and which are not so. In terms of success, we've seen that larger municipalities, due to their commitment to the technology, tends to be much more successful. There is always an initial adoption pain, because what we see from the field services workers is that adoption at the front lines tends to be slower because people resist the change. It often makes sense to do the job the way you've always done the job, even though you can save half an hour today. People just don't think that way quite yet. And what we've seen as a general trend in the industry is that municipalities, especially larger municipalities, that made a conscious effort to adopt the technology, and in a way they forced their employees to start using it, even though it can be very uncomfortable for the first couple of months to apply it everywhere. they tend to be really successful. And we've seen quite a bit of growth with those municipalities. For the smaller municipalities, we've seen a mixed bag because of the cultural issues. Sometimes it's very difficult for people to change. It's very difficult for people to start pulling out an iPhone, pointing at the ground and see the pipes. It's much easier to go traditional ways. So commitment is required to get started with the system. But before you get to that point, you need to have good data. Data is paramount because if you want to visualize things, information will not appear out of the void. So you need to have at least some data that you can put to good use.
All right, thank you, Alec. Chuck also wanted to add to that answer. Go ahead, Chuck.
Yeah, one other thing that I think is a really good idea that, as the designer of some of this equipment or designer of some of these projects is that we're seeing it a lot more in municipalities globally is during the RFP process, it's written into the RFP, whether that comes through infrastructure or capital improvements, that one of the deliverables, is actually a spatially accurate 3D model. Like I said, a lot of this equipment, a lot of this data is being designed during the design phases. There's no reason why it can't get used by you afterwards. But a lot of times, just because it's an extra step for designers or developers to take on, they don't turn over the 3D information at the end because it's something else they're liable for. If you are able to write that into the requirements, into the proposal documentation, you'll start to just sort of organically start to build up accurate 3D information. And this is where you need to actually bring someone in, probably as a consultant, to make sure that you're asking for the right stuff. But the point is that your 2D deliverables, your plans and roll plots and whatnot are great, but moving forward into a larger capital investiture, you should be requiring spatially accurate 3D information that is registered to the real world. So that even if you don't have the ability to use it right now, in 3 to 5 years, you'll have a library of this stuff built up. It also makes it easier to supplement areas that might be lacking in information.
All right, thank you, Chuck. Ashley also wanted to add to this answer.
So I just want to really emphasize and echo what Alec had said about the importance of data, and this is going to be a change in culture just because it's something that's brand new. One of the pain points that we had, and remember when I said this, we started 2 to 3 years ago, is just the adoption, and that's not an AR thing. That's a something new. It's a change, and whether it's good change or bad change, it's change, and change is not always received very well. So if you have accurate data and you have robust systems like asset management and GIS where what they're putting on their head or using in the field to see data is accurate and they can start trusting that, this is just going to be icing on the cake for people. And one of the things that we really found success in was finding a true need. It's not just a cool thing. It's not just a wow factor. It is, we truly have a need for this. How can we use AR to help make someone's job easier? And that's where we had a breakthrough.
Thank you, Ashley. The next question is from Randy. Have you seen adequate accuracy in the positioning of the digital overlay when using existing device GPS? And are there external antennas preferred? And I believe Alec was going to start with that answer.
I will jump in front of the queue. Thank you. The built-in positioning tools that you have in consumer-grade electronics, such as tablets, phones, Hololens doesn't have any positioning devices, but tablets and phones are insufficient for augmented reality at all. So if you look at any application in general, I shouldn't say for any, because sometimes you can use image recognition when the device can simply see and recognize what's in front of them and then overlay images on top of that, but it's a completely different story. If you're relying just on GPS and compass, then built-in GPS and compass will be insufficient. Your accuracy can jump anywhere from 5 to 50 meters, which is 15 to 150 feet. and you can be really far off from the actual location. Because of that limitation, you probably noticed that Google recently released optical scan, when it allows you to scan the panorama of the city around you, and then it will determine with high precision where you are. For utilities work, that wouldn't be sufficient either, because it will place you within a meter or two, maybe 5, from your location. And therefore, if you're looking purely at the utilities grade job, then you will need some alternative method of calibrating or positioning in the field. With our system, we actually patented a calibration method that allows us to use aerial maps and optical tracking to get you to about 10 centimeter accuracy with good aerial maps. It has its own shortcomings because of the limitations of the optical tracking, but nonetheless, you can achieve that by using methods alternative to GNSS devices. When it comes to survey grade work or construction work, this is where it's unlikely that you will be able to move away from high precision GNSS or RTK tools. You would be looking for sub 10 centimeter, sometimes centimeter accuracy. You will be looking for accurate direction to make sure that your device maintains its heading in space. And the only way to achieve it is have a device that provides you better than 10 centimeter accuracy, guaranteed accuracy. So it's really up to you how to position those, because depending on the application, you can mix and match different tools. But if you're thinking about deploying devices just with the built-in GPS and compass, unless you're talking about object size of the city, it's the success rate will be fairly low simply because of the positioning limitations.
All right, thank you, Alec. And I believe Victor wanted to add to that answer as well.
Good morning. Thank you, Randy, for your question. The short answer to that question is no. The long answer is it depends on what your application is. We've used augmented reality for several different scenarios. One was public outreach, where we were placing a building on a street end, and the accuracy wasn't necessary. We had a bunch of John Q. Publics out there, and they wanted to see what this building looked like on the street. So we just had them looking at the new proposed building through an iPad, and I had them walk around and see what the building like interposed with their buildings from the front, the sides, and the back. We've also used it to identify underground utilities, and the accuracy just was not there. But understanding that the accuracy is not there, we do get a good idea of where these utilities are underground. And instead of going into the situation completely ignorant, we have a great idea of where to begin. And I think as the technology improves, as GPS and our small consumer devices improve, that'll get better. But in the interim and in the meantime, we have to understand the limitations of our augmented reality and work accordingly. Thank you.
Thank you, Victor. The next question, I think, Victor, maybe you were going to start with the answer, so we'll stay with you. Is there any drawbacks that you want to talk further about with using the AR in addition to the accuracy that we just talked about?
Well, Randy, I'm glad you asked that. Accuracy is a huge issue, especially if you're trying to verify utilities underground, or you're looking for something specific and you've got to find exactly where it is. Our surveyor's going about and he's put all our monuments and we're trying to find monuments using AR. So if you have it in a big model, you can go out and look for it. And he's had to dig a few times, and that's not fun. So accuracy is one of the huge drawbacks to this technology, and also the size of models. Packing all that into an iPad that's got 64 megs of information, or trying to get a good signal. We have 5G coming soon, but 4G and a big, huge model just does not work so well, and you get a lot of lag time, and it gets sketchy and jumpy, which can be frustrating at best. Thank you.
All right, let's see. The next question is, what are the advantages of AR over other methods of accessing the same information? I think Alex was going to start that answer.
Oh, I keep stealing thunder from everybody. I think Chuck covered it really, really well in his presentation, and it makes sense just to focus on this specifics. Coming from the utilities world, if you look at the essential steps that a person takes in order to understand the paper-based map or two-dimensional map, then the person looks at the map, and then they first create this mental image in their head. And some people are really good at reading maps. Some people are not good at reading maps and understanding information, translating in 3D visuals. In the end, you have to have that mental image created in your head, and then you have to use your imagination or your skills to match that mental image to the physical surroundings around you. No matter how good you are, this process is time-consuming and error-prone. Time-consuming because you have to read the map, you have to understand all the complexities, all the nuances of the data, and then you have to look around and match it to the physical world. Error-prone is because humans are not ideal at retaining information, and therefore, when you create this mental image, while you're working on something, you may simply forget that there was something else, and the most common issue in the utilities industry is that somebody was tracing the main line and they forgot that there was a lateral line. And the line strike occurred not because of the incorrect locate, but because somebody simply forgot that there was something else. With augmented reality, when you create that visual overlay on top of the physical world, any deficiency in your understanding will be eliminated right away. You get almost instant situational awareness. You can simply see where things are and how they relate to the physical world. You can also see where the small things that you would have missed otherwise are. And as you move around, that image stays where it's supposed to be. And therefore, if you got distracted, if you had to do something, send a message, trace a line, change equipment, that image will stay there. You don't have to reintroduce yourself to the surroundings. And that's the biggest advantage. It saves on, especially large locate jobs, quite a bit of time. Another, and I don't want to be very long with this, but another big advantage is something that Chuck mentioned about BIM data, when you visualize construction data before something is constructed or during the construction process. This is where you can detect clashes way ahead of time. This is where you can match your designs to the physical surrounding to see if they make sense. And this is where you can monitor your construction progress and avoid really costly mistakes that happen just because of miscommunication or some other issues.
Thank you, Alec. The next question, we're going to find out from our two municipalities what's next. So first, Ashley, can you tell us what's next for Auburn with augmented reality?
So what I alluded to a little bit with some of the accuracy concerns. We've started using it in ways that we are not really too concerned about accuracy, just to kind of get the ball rolling a little bit, and that gets back to those business needs. We have talked about it in terms of, implementation with a 3D model and being able to see things as they would be in a proposed state. We've also started messing around with drones and getting the drones to go to places that it's just not very feasible for humans to go to, and then streaming that AR back to a person holding device and kind of being able to interact with it from that standpoint. So we're staying away from the high accuracy and leaving that to the survey folks and some of their high accuracy equipment, and getting back to some real world examples of how we can use it, which in this case is proposed stuff and getting to places that humans cannot with drones.
Thank you, Ashley. And Victor, what's next for the Port of San Diego?
Well, we're at the Port. We're going to continue with our AR development, and as Ashley mentioned, We're going to try to stay away from some of the high accuracy things, but being a public agency, the public determines what we do, and so we want to be able to communicate what our goals and what our projects are, and the best way to do that is in some easily digested method, and AR happens to be one of those things. So our public outreach and presentations and things of that nature is where we're focusing our AR right now, so that we can communicate complex thoughts and ideas into something that a lay person can fully understand and comprehend. Thank you.
Thank you, Victor. Next question, I think Chuck's going to start with the answer. Can you tell us what's holding back AR from being as broadly adopted as VR is?
Yeah, sure. I mean, there's a lot of reasons. Like, there's a very technical answer, and is that the thing that makes VR manageable is that it doesn't involve any other kind of media other than the one in front of your eyes. You know, VR goes so far as to completely isolate you in its own self-contained environment. It even, a lot of them put headphones over your ears so that you don't have acoustical information. So you are building a very, very controlled environment in VR, and you are allowing people to get in there and move around in it, but there's no reality to it. It's all virtual reality. Augmented reality on a very technical level has a much harder time for the reasons that we've already talked about, with the global positioning and the relative positioning, to bridge that gap to the highest level of accuracy, because it has to be married to the real world, right? It's part of engaging in the ecosystem. Like, you got to be part of it. And augmented reality requires some additional hardware and additional software, and honestly a level of data information that is just not available everywhere yet, you know, unless it's built in BIM or it's been scanned into some sort of reality. You are still very much relying on the manual registration or the manual input of a lot of this information. So while technically all the components are there or are part of the evolution to make this there, there's still a lot of legwork to supplement this, they call it the global persistent cloud, where everything will eventually have data associated with it. But there's a ton of work that goes into it. Now, the upside to that is that you have billions of cell phone users who are casually scanning and recording information, but now you get into honestly the global debate of personal privacy and whatnot. I'm sure it's for another day. But the reality is that because augmented reality has to constantly measure up to the real reality, we're not to the Matrix or the Oasis yet. I mean, that data doesn't exist. So there's this giant data gap that augmented reality is tasked with covering, and that's a tough one. You know, virtual reality is hyper-controlled. Augmented reality is out in the wild. So that's kind of why augmented reality is lagging below, because culturally and technically we have a few gaps to cover on our own.
Thank you, Chuck. Looks like Colleen sent in another question. What do citizens and councils think of these AR initiatives? Are they on board with them? How do you justify the cost and communicate the ROI? And Ashley's going to start with that answer, followed by Victor.
Great, thank you. So one of the, I guess, real things that we're lucky with is we do have a very involved and supportive mayor and council on some of the things that we're doing as it relates to innovation. And, you know, as long as we, you know, we talked about this a little bit, but the citizens do drive a lot of what we're looking at doing. And what we really went through on this particular implementation, if you will, is, if you remember, I talked about we have a very robust asset management system. We had a very robust GIS system, and we felt that our data was really, really good. We also have field devices where all of our field workers have a multitude of devices that they can choose from on what they best prefer to use in the field. Most of them use Apple products. So we already had the data in GIS. We already had that being synced up with our asset management system. We already had field devices, and all of those were talking to each other in the cloud. So we use basically cellular connections to have all those things tie together in the field. So the only thing that we were really adding in this whole thing was just that AR piece that sat on top of it. So our expense, our initial investment in this was very, very inexpensive. We're talking a few $1,000s to not only show a proof of concept, but pretty close to full implementation, because the licensing was simply just that. It was the licensing for the software. We don't have any other expenses outside of capital costs that we've already made previously. So our discussion was very transparent in what we're trying to accomplish to our council and subsequently to the citizens on, here's a need we have. We believe that we can solve this need very inexpensively, and it hits our innovation checkbox. It hits a way to save money checkbox. It hits all of these different things, and at the end of the day, it works. And again, it's something that people resonate with. And, the drones was a very similar discussion. And, sometimes when you say AR and drones and things like that, people say, oh, well, that's just, they're messing around, or that's just because it's cool. No, it actually has very, very high value to what we're trying to accomplish. And we did it very inexpensively.
Thank you, Ashley. Victor, did you want to add to your experience?
Yes, I would. Thank you very much. Citizens typically, from my experience, have really embraced it because it is what's actually going on. As we saw at the beginning of this presentation, the AR is prevalent in our lives all day, every day, from the Snapchat filters to the Google Maps AR. It's out there. So John Q. Public is already aware of AR being there. And for us as a government agency to not provide for our citizens what is actually out there does a disservice to the community. So in doing that, the citizens are with it, the council's with it, because we are providing that same service that people expect. Public outreach is part and parcel for what we do. So there's not really any additional cost to doing this because we're reaching out to public and we're communicating what we have going on. So there's no serious additional cost to that. And the return on investment is having people understand what we're doing, and we get better buy-in, we get better funding, and better understanding of what we are doing here at the Port of San Diego.
Thank you, Victor. This hour has gone really fast, and that is all the time we have for today. I want to thank Chuck and Alec and Ashley and Victor for sharing their knowledge and experience with us. This is Rita Cassida, and it's been a pleasure moderating this program for you today. You need to keep an eye out for the January APWA Reporter article that will be announcing APWA's top 5 trending technologies for 2020. So we'll see what's going to happen next year. Following the announcement, enrollment will be open for the 2020 Talking Top Tech webinars. Please don't forget to fill out the evaluation form. The link to the survey will be emailed after the program today. A recording of today's program will be available in the APWA's members library and on YouTube within a week. APWA members can log into the library to access past Click, Listen, Learn, Talking Top Techs, and conference content free of charge. Not an APWA member? Take the members library for a test drive. Spend 2 weeks accessing all the materials in our members library for free. Look for the link to sign up in your email today after the program. Thank you for your attendance and participation during this program, and have a great day.